Okay, this video is going to be about experiment number 4, and as you can see, I've got a little proto board, and on the little proto board here I've got a 1.2 k ohm resistor, a 0.1 microfarad capacitor. The test leads on the left provide a signal from the signal generator. The test leads on the right are going to the oscilloscope. The oscilloscope is also watching the input at the same time. So it turns out that if I take and scan over to the oscilloscope, what we'll see, hopefully, is face of the scope, and hopefully if we don't wiggle too much here, we'll be able to also make out the values. And so I think I got to move this over a little bit further. Bear with me. And again, I'm not very happy with seeing the values there. I don't know how well you can see them. Let's see, I don't know how I do focus here. Automatic focus. I'll click on it. Oh, it was there before. Oh, there we go. Oh, that's very nice. Okay, so we'll leave that there. And let's see if we move like this, we can almost get the entire screen in. Okay, so the first frequency, first measurement is 100 hertz. And the output, the input is 4 volts. That'll stay the same. That's signal number 1. Signal number 2, the output is 4 volts. The phase of 1 to 2 says 8.24 degrees. Now, this scope makes automatic phase measurements, but how good they are and how much you should believe them is a little bit mysterious. But you know, when we're in the middle of the measurements, they'll be pretty good. As we get to either end, either very low frequencies, very high frequencies, they're quite suspect. So I might make more comments about that. I'm going to go to my signal generator and turn it up to 200 hertz. And what we have for measurements is still basically the same. I'm going to go to 400 hertz. The next measurement, I'm going to take and change my oscilloscope time display. You might see that the green, number 2, the output, it's tough to see which one is which here, but the green is the one that's delayed a little bit. And you might see the delay angle, well, now the voltage gone down to 3.96, and the angle's at bouncing around there, 9.7 degrees. So that's 400 kilohertz. Excuse me, not 400 kilohertz, but 400 hertz. Let's go to 600 hertz. I'll leave that there for a second. Output 3.9 volts now, and about 13, jumping around 13.7 degrees. The scope does have an average that I can do on these measurements, but let's just leave them as what they are. Let's go to 800. Next reading, 800 hertz. We're down to 3.84 volts and up to about 16.75 degrees. You should be filling in the grid on your experiment. There's a table that you can fill in for these laboratory measurements. Go to 1 kilohertz, and now on 1 kilohertz we see an output of 3.76 volts. The input's still steady at 4, and we're up to about 20.2 degrees at 1 kilohertz. Our next reading is going to go up to 2 kilohertz now, so I'll go to the signal generator, go to 2 kilohertz, adjust the oscilloscope a little bit. Now you can see on the oscilloscope how the green or output signal is delayed in time. And see the 2 cursors that are vertical, those are taking a look at the time delay and calculating that there's a phase angle shift of about 35.5 degrees. That's at 2 kilohertz. If I go to 4 kilohertz, now you see that the outputs drop down to 2.27 volts, and we're talking 54.4 degrees. We've gone past the 45 degree angle. Let me see if I can go and find what frequency the phase shift is. About 45. Let's go back to 3. Now it's at 46. It's pretty close. I'll go down 2 and take a look. 2.8. Just about 2.9 kilohertz. It says we should have a 45 degree phase shift. That would occur when the reactance of the capacitor and the resistance of the resistor were equal in amplitude. Now again, these phase measurements are a little bit suspect if you ask me. So I'm not too sure. It says 2.9 kilohertz this occurs. I'm not too sure that should be the case. Seems to me it should be something like 1 over 2 pi RC. But far be it from me to question the measurements from this fine oscilloscope that we have here. Anyway, it says that the phase angle there is 45 degrees at 2.9 kilohertz. So let's go back. I can't remember what the last one was I did here. Probably 4. So I think, yeah, 4 is 2.27 and 54 degrees. So now let's go up to 6. Here's your next measurement. Voltage down to 1.67 and 64 degrees. It bounces around a little bit, 64 degrees for a phase shift. Let's take and go up to 8 kilohertz. We're down now to 1.31 volts, and the phase angle is about 70 degrees. The phase angle bounces around a little, but the cursors appear to be quite steady. So we'll go with 70 degrees for the phase angle. We'll go up to, the next one is 10 kilohertz. So at 10 kilohertz, now you notice, by the way, the green one's getting very small, down to 1.07 volts. And we're up at 74 degrees for a phase shift. I'm going to go up to 20 kilohertz. And at 20 kilohertz, I'm going to take and do something with the scope here. I'm going to take and have fewer waveforms. And now we're up to about 78 degrees and down to 580 millivolts. Now, at this point in time, I would tell you the phase angle measurements are going to get suspect. So I'm going to go up to 40 kilohertz. And notice that the phase angle just bops around a little bit at 80 degrees. 300 millivolts for the output. I'm going to go up to 60 kilohertz. I'll vary my scope a little bit here. Probably going to turn up the gain for the output. Let's do that. We're up to 84 degrees about for the phase angle, down to 191 millivolts for the output. That's at 60 kilohertz. Let's go up to 80 kilohertz. At 80 kilohertz, the phase angle still is around 84 degrees. Again, suspect at this point. The amplitude 143 millivolts for the output. The outputs drop down to 3.84 volts for the input. The inputs drop down 3.84 volts, but I would just leave that at 4 in my chart. And let's go up to 100 kilohertz. 100 kilohertz now, we're down to about 117, 118 millivolts. We're still around 84 degrees. That's probably going to stay there, maybe even go down as we go up a little bit further. So now our next measurement is, we're at 100 kilohertz now. Let's go to 200 kilohertz. Notice the phase angle now is very suspect. And even though I might bring that amplitude up on the scope, it doesn't seem to make much difference here. As far as, now we're having trouble with triggering it. It's dropped down from 84 to 82 degrees. So again, I'm not very happy with the phase measurement here at this point. We're down to about 61 millivolts for the output at 200 kilohertz. Let's go to 400 kilohertz. I think our last measurement. And try to stabilize this a little bit. Let's hit the stop button here. Notice the phase angle now is 77 degrees. The amplitude's 32 millivolts. So about 400 kilohertz, 32 millivolts for an output. Okay, that'll be your data for the chart that says laboratory measurements.